Okay, so we're going to spend the next 35 minutes talking about candidate therapies and the latest work in animal models. So I will kick it off, and I will have Troy Lund from the University of Minnesota address some of the slides, and then we'll end with Josh Bonkowsky from the University of Utah talking about his work on the zebrafish model. So I think most of you in the room know me, but I'll give you a quick summary of my journey. I will be turning 51 next week, and I was diagnosed in 2011. Really started showing symptoms around the time I turned 40 years old. So I'm a relatively late onset and started having the typical gait and bladder issues, and went through a 2-year diagnostic odyssey until I was diagnosed. And I live in Palo Alto, and I met Florian Eichler in early 2013, at which point he invited me to be a founding board member for ALD Connect. So I've been very involved with the community. Brian, Justin are friends. We've gone through this journey together, and also have worked with the medical community to find therapies for us. Next slide, please. So basically, one key question is, of course, how do you maintain function and quality of life, and the essence of who you are as a person, as a member of your family, as a working person, for the long term. And so one thing that I've particularly emphasized is, of course, exercise, physical therapy. So it varies by people, but I think everybody will agree that physical therapy and exercise are extremely beneficial for health in general, for cardiovascular health, for mental health, and also to keep strength, core strength, mobility, balance, to prevent falls. And so, whether you swim, you do a stationary bicycle, you do Pilates, you have a trainer who shows you how to do hip flexions and pulleys and balance exercises. It's absolutely key to exercise 3, 4, 5 times a week, and really just absolutely force yourself to do that. I think a lot of us are dealing with spasms, which are particularly troublesome at night because they prevent you from sleeping. And so we have a variety of anti-spasm medications from things that can be taken orally, like Zeneflex, to, of course, the famous baclofen pump. But I think a lot of people are dealing with these feelings of, terrible peripheral neuropathy and restless leg, and feeling like you have red ants in your limbs. We also know that I think about 70% of men with the disease have chronic adrenal insufficiency, whereby daily supplementation with steroids is the standard of care. And that's, of course, very important to regain your health, regain your energy, and avoid an addisonian crisis, which could be catastrophic. Next slide, please. So in terms of experimental therapies, I am not the expert on Lorenzo's oil. I know a lot of the boys who are being monitored very closely are taking Lorenzo's oil. There are still some adult men who were part of the initial pilot who are on Lorenzo's oil. I know for myself, when I was diagnosed, it was recommended to me not to use Lorenzo's oil for a variety of reasons. But that's still, a treatment that is being used, and really on a case-by-case basis. Antioxidants, I would say the antioxidants, have been talked about a lot at Ida. Aura Pujol from Barcelona showed during a number of years her antioxidant cocktail, very potent antioxidant cocktail, and really with the goal being to reduce oxidative stress, to reduce inflammation, to really kind of throw a monkey wrench in that kind of spiral of oxidative stress and inflammation and neurodegeneration. And the antioxidants showed great results in the animal model, have been a little bit inconclusive in humans, but I think the consensus is that antioxidants cannot hurt, they can only help. And so I myself take a cocktail of about 8 antioxidants every morning, and then every 3 months or so I do a 3-week washout. The idea being that the body has to be reminded how to produce its own antioxidants. And I think they've kept me, probably in somewhat better health than if I were not taking antioxidants. And PLA is the only pharmacological drug that I do take. I actually take only 1 dose every morning. And it is a drug for MS patients, which is supposed to help with fluidity of gait. The buzz I'm hearing from our adult patient community is that it doesn't work for everyone, and the benefits are not enormous, but they can be substantial. So in my case, I've tried it, I've gone off it, I went back on it, and I've noticed an improvement in gait that lasts about 5 to 6 hours, just a more natural, more fluid gait. And one challenge that a lot of patients have faced is that PLA, the only official indication in the US, at least as of today, is multiple sclerosis. And so a lot of patients are having it made under the name of 4-aminopyridine, the active ingredient, by compound pharmacies. And you have to find a good compound pharmacy that you trust, which is going to make the drug for you. Next slide, please. So gene therapy is, of course, the great hope, particularly for the boys. I think, we're delighted to have the huge presence from Bluebird Bio here today. They've been a wonderful partner. And their autologous gene therapy, where they take, of course, the cells from the boys and they reinfuse them, with essentially the corrected gene into the boys, is the great curative hope. And so they conducted the StarBeam study that has ended. They analyzed the results. And the wonderful development is that they've decided to continue and expand the study, and so that's going to be expanded in the US and in Europe. They're also launching ALD 104, which is really an effort to gather information about adult cerebral ALD from past medical records and try to derive insights, find patterns from that. Next slide, please. So that's a slide that I think is quite exciting and quite meaty. When I was diagnosed in 2011 and I surveyed the landscape, it was really disheartening. Just, aside from the antioxidants being tried in Spain, there really wasn't much to hope for adult patients. And so what's very exciting today is we have 3 viable candidates So the one that is probably the furthest along in the US is Neurovia. Catherine Norris is present at this meeting. And Neurovia is based in San Francisco. They're well funded. AMN is at the top of their ALDs, at the top of their pipeline. And what it is, it's a thyromimetic, so it's an old concept that came out of Tom Scanlan's work at Oregon Science and Health University, and it could potentially trigger overexpression of ABCD2. So we know ABCD1 is the deficient gene in our disease. ABCD2 is kind of the backup, and if you can kind of trigger, upregulate ABCD2, it could have a beneficial effect. So they're going to have a short phase 2 study for safety and efficacy, probably starting in the February to March timeframe, out of 5 or 6 centers in the US. And it's going to be short, it's going to be a small patient sample, but I would really encourage people to enroll because we need to learn more about the disease, to learn more about this therapy, and we need to start somewhere. Another candidate is Minorix Therapeutics in Barcelona, also quite well funded. They have a drug called codename MIN-102. It's a derivative of pioglitazone. So it's a PPAR gamma agonist, and it enhances metabolism of very long-chain fatty acids. So that's an idea also that's been around for a long time. Aura Pujol was kind of had the initial idea, really believed in that, and they are planning. They're really kind of in the early stages of planning. First, probably a European study, and then a US study. And then Mede Pharma in Paris has a compound called MD1003. The study that they've run in Europe was funded by the European Leukodystrophy Association, and it's basically high purity, high grade biotin. So you can buy biotin in the US, as a supplement, but this is, 30 times the highest dosage you can find off the shelf. And it's been proven to be effective in MS, and they've tried it with a 75-patient 2-year study where miraculously nobody dropped out, everybody stayed in the study. And they were just very close to reporting the results on that. And we're very hopeful that it will show improvements in remyelination, neurological function in AMN patients. I will turn it to Troy.
All right, I'm just going to talk on the next couple of slides as we tag team this presentation. For hematopoietic stem cell transplant, we are performing this in adults with cerebral ALD. We've probably done it now with 8 adult patients over the last 5 years to try again to arrest disease progression. We don't offer transplants to adults with solely AMN. They do need to have cerebral involvement. We kind of decided as an international group a few years ago at a meeting in Germany that this would be part of the criteria, so that they need to have full-blown cerebral ALD. The European group actually has a good cohort of 12 patients yet to be reported on, but the manuscript is nearly finished, in which they performed transplant and have arrested the cerebral progression. So that's pretty good news. Transplanting adults is a lot different than transplanting kids. It's not exactly the same in terms of risk factors. So there are lots of things that are discussed during these interviews when we talk to adult patients that want to consider this. And then there are other risk factors that may tip a patient towards poorer outcomes. Those risk factors include more time in bed, poor mobility, concurrent or active infections like UTIs. All of those risk factors kind of stack up for the adult patients, and those patients tend to do poor after transplant, as an aggregate. So we want to consider each patient individually, and we have lots of one-on-one meetings when we see these patients.
But the short story here is that current modalities for gene therapy that encompass what Bluebird is doing right now are very effective in correcting stem cells outside of the body, getting them back after a brief chemotherapy and moving from bone marrow to blood and blood to brain, but it doesn't cover the spinal cord very well. And the spinal cord is really the part of the body that we're most worried about in AMN, and hence we're looking for different approaches. And what we found is that different virus, such as AAV9, is very effective in immediately transducing cells, particularly in the spinal cord, and is at least in preclinical animal work showing very good effects, and is now really becoming transformative for spinal muscular atrophy as well as for other peripheral neuropathies like giant axonal neuropathy. And I think as we are seeing progress happen there, we're now trying to leverage that through work on the ALD mouse model and have correct biochemistry, and we're getting into the right cell types, and first data are suggesting behavior improves.
Yeah, so maybe I'll cover that. So, that's a little bit bringing my patient perspective. So, obviously, to be successful with therapies, we need to have the plumbing, the data infrastructure, and I think, Alex and Justin covered that. So it's the repository of patients, of biomarkers, of the natural history studies, so that you do have the data to launch, to leverage, to launch these studies. It's also enrolling patients. Some of the studies are going to be time consuming. They're going to have logistics, complicated logistics. So we need to work together to make sure that patients can enroll, see the point of the study for themselves and for the greater community, and stay engaged in those trials as active, empowered patients. So they're not just giving specimens, but they're truly engaged in being part of the study, reporting outcomes, reporting endpoints, and telling the team what matters to them. We of course need all the biomarkers, the progress in terms of the imaging studies across various MRIs and types of equipment. We need to prepare the regulators. So I think a lot of members on the team, Amber and Rachel Salzman have been driving a lot of that. They've visited the FDA. They explained to the FDA, where we are, what matters to patients, and to give the FDA a deeper understanding of what we're trying to accomplish. ALD Connect, that's kind of the big plug for ALD Connect. ALD Connect is essential for this because it is the type of consortium, the umbrella organization. It's not only the best PIs across the country, but it's the infrastructure, it's the patient engagement, it's the engagement with biotech. The feds are not going to fund anyone. They're going to fund a vehicle like ALD Connect. And so we're the exact type of platform to go after those grants and launch those studies. And of course, funding both from individuals, foundations, and government like PCORI and the National Institute of Neurological Diseases and Stroke. Next slide. So very quickly, you know, one thing that I think we've all done and have teamed up with some of the PIs at ALD Connect is to scout for small biotechs that may have a small molecule of interest. And so I just wanted to look at the past. We have been in contact with a lot of those companies, and there are probably some that are not on the slide. And basically a big difference, you know, the difference between these guys and Neurovia or Minorix or MedDay is that these guys, they're not, you know, they keep an eye on us, but they're not as interested. You know, ALD is like number 8 on their pipeline. They have not necessarily assigned funding to ALD. So when they come to us, they say, you know, do you have 150K to give us to do an in vitro study? Well, you know, others like Neurovia are making plans to do a phase 2 safety and efficacy study, you know, across 5 centers in the US. So big difference. So these guys, you know, their molecules could work, but we don't have, you know, an active engagement with them at this point. That doesn't mean that, you know, we still want to hear, if you hear of a biotech that has a, you know, a compound of interest, we'd love to hear about it. Now we're ready for Josh. So Josh is going to talk about his latest pioneer work on the zebrafish.
So thanks everybody, thanks for the chance to talk. So I'm Josh Bonkowsky from the University of Utah, and I'm a pediatric neurologist, so I see patients in clinic, and then we also have a research lab. And in our lab, we're using a animal called zebrafish. I think in the next slide, I have a picture. And so zebrafish, something that you may see if you go to the pet store, it's this small fish here. When they're adults, they're about 1 inch long, and they have the same biology that we as humans do, so it's the same genes involved in their development. The process of myelin formation occurs the same in zebrafish as it does in humans or mice, and this is all happening very quickly. So I think the big advantages of zebrafish, as I talk about here at the bottom of the slide, is that they're inexpensive to work with. So instead of screening or working with 5 animals a day or a week or a month, you can screen thousands of animals a day. So it's just the feasibility of doing large-scale screening is tremendous, and the cost of screening is much smaller than any other vertebrate model system. And so we're a kind of a medium-sized laboratory, and we can screen through compounds at an early stage of life, at early processes of disease, for, you know, in the orders of hundreds of dollars instead of in the order of tens of thousands or hundreds of thousands of dollars. And so we have developed a zebrafish model of ALD by mutating the ABCD1 gene. And we've done various things, and so because I'm just trying to present quickly here, we've done various things to kind of validate this model. So it has elevated very long chain fatty acids shown in this picture here, similar to the human disease model. We've done other markers for myelin biochemistry showing that it loses myelin. I think the most interesting thing to us is that there seems to be very early in development a problem with how the myelin forms in the mutants, and so we think, I mean, we don't know for sure, that this problems early in development are what are kind of laying the groundwork, so to speak, for the problems with disease we see later in life. And so the final point with using zebrafish that I want to raise is that there's many promising compounds that we've all been hearing about today, but like in any sports game, if we want to use a sports analogy, that if you're not taking shots on goal, you're not going to score. If you can't score, you can't win. So we want to try and get as many shots on goal. And so with zebrafish, we hope we can kind of increase the front-end throughput so we have more shots on goal, so we have more potential therapies that we should be investigating. So in the next slide, we have kind of 2 unique tools that really kind of add extra power for our system. And so this is a picture magnified of the zebrafish brain, kind of looking down from the top side. And in the brain, we have a GFP, a fluorescent reporter that lets us see the myelin in real time in the animal, so we can actually see if the myelin's there, or we can see if something's happened to it. And then the second thing is this is a blown up picture of a 96 well plate, which is about the size of the iPhone 6, you know, if you've got your iPhone 6, so it's about the same size. In each well of these 96 wells, there's an individual zebrafish that's about 3 or 4 days old, and we can monitor all 96 wells at the same time. And so these are individual tracings of the animals that we can follow with an automated camera setup. And so with our system, we see that the mutants in ALD have a behavior defect. They have swimming or motor impairment, and we can see what happens to them by monitoring all 96 wells at the same period of time. And I think in the next slide, the general concept is that we can look at the 96 wells. We put individual 1 or 2 animals in each well, add a drug to each well, a different drug in each well, and then a day or 2 later, because the disease progresses so rapidly in zebrafish, we say, you know, are there any animals that are still okay a day or 2 later? And then you say, well, what is that drug in that well? And so we are looking at both kind of known compound libraries, so can we repurpose existing drugs, as well as can we discover new drugs with this process? And I can't remember if I have one more slide or not after this. Okay, the final thing I want to point out is we're very excited about using this to discover treatments and drugs that would help prevent disease, right? That's the purpose of this, of what we're trying to do here. The other thing that's been a big question in the field is why do some people kind of develop an early childhood devastating form of ALD, so kind of the childhood cerebral involvement, and why do other people develop kind of a chronic kind of, you know, later in their 20s or 30s, the AMN process. We don't know the answer, but with this screen, we'll be able to pick up drugs that cause worsening of the phenotype. So are there animals that then instead of doing okay, they actually get worse very quickly? And so our screen can actually pick up the pathways involved in why the disease gets worse, which I think may open up new kind of avenues for research for understanding cerebral ALD. Ben, did you have a?
So one question is, of course, this compared to the mouse model, is it complementary? Is it better in terms of time, in terms of cost? Is the mouse model imperfect?
So that's a great question. So we're against the mouse model. No, I'm kidding. So it's a complementary approach. So I think the big advantage for zebrafish is the power of the screening that we can do quickly. So in our lab, which is again kind of medium-sized, each day we can screen on the order of 500 to 1,000 compounds. So in a week we can screen on the order of 2,000 to 3,000 compounds when things are going smoothly. And the cost of that is in the order of $5,000 to $10,000 over the course of 6 months. The disadvantage, of course, is that some people point out to me that zebrafish are not people, and so anything we find in zebrafish will need to be validated in a mouse model and then in human studies, but it kind of helps you focus in on candidates that are promising quickly.
So I'm just curious to know what drugs you've used and if you've found any that are more promising than others.
So we don't know yet because we're just we're starting with a very standard chemical screen. We call it the microsource spectrum collection. Its advantage is that it's known compounds that have been previously FDA approved for other diseases, but that don't work particularly well for that disease. So, for example, a blood pressure drug that doesn't work, but because it's been approved in humans, if we find a hit there, then it'd be very easy to go back and say, can we go back direct to human studies for that drug? The other category of compounds in that collection are natural compounds, where they kind of open up the avenue for novel drug discovery.
I'm Risik Jung from South Korea. I have 2 questions. In zebrafish, ABCD1 mutation is fatal or non-fatal?
Does the mutation is fatal to some of the fish. So the mortality rate is about 30% over 2 weeks, and we don't understand yet if it's really matching the human phenotype or if it's something separate. So I don't know for sure why they're dying.
Okay. And second question is, how much similar lipid metabolism between zebrafish and human?
How similar are the genes? Is that
how much similar lipid metabolism between human and zebrafish? I think that there's very different.
So that's a great question. So there's, I guess the best way to think of it is that there's been other screens for drugs, not for ALD or AMN in zebrafish, for cardiac drugs or for epilepsy drugs, which have found hits and been used for humans. And so I think that the metabolism, although there's differences, the overall gene and protein similarity is about 80%. So it's not a guarantee, but it's pretty high. Troy?
Yeah, Josh. So from our point of view, we think a lot about the immune system and immune dysregulation, which may play a role in the whole spectrum of ALD diseases. Is there a way to incorporate that into this model somehow?
So that's a great question. Because there's such a wealth of information about ALD and AMN, we feel like we've been trying to just standardize everything about understanding the disease in zebrafish. And so the immune system is conserved in zebrafish in terms of T cells and B cells and natural killer cells. We are hoping that with this gain of function screen where we're trying to make the disease worse, that we may pick up things that are dysregulating the immune system and that are kind of contributing to kind of the rapidly progressive form of disease. But we don't know that. We're just hoping.